So the area underneath a curve can be calculated if you set up a definite integral. So we now know the 2 points that we're talking about on our curve, the 2 points of intersection. So I now need to integrate that y equals x squared minus 1. I need to integrate that and figure out the value of the definite integral between 1 and minus 1. So first step, I need to integrate x squared minus 1 with respect to x. If you remember, you add 1 onto the power and then you divide through by the new power. So that gives us x cubed over 3 minus 1x. And we always get this constant of integration as well, but more on that in a second. We don't actually need the constant of integration when we've got a definite integral. So I'll show you why in a second. Anyway, we need to figure out the difference between these two values now that I've got my integral. So I substitute 1 in and I substitute minus 1 in and I figure out the difference between them, so I subtract them. So you'll see what happens. I'm going to have a positive c on the left hand side and then I'm going to subtract a positive c from that over on the right. They're going to cancel each other out. And that's why we don't need to worry about the constant, but only when we're figuring out the area underneath a curve like this question is. So after a bit of substitution, a bit of calculation, you should figure out that 1 cubed over 3 is a third, take away the 1 is minus 2/3, and the other bracket actually equates to give 2/3, a positive 2/3, but remember that we're subtracting that. So you have minus 2/3, take away 2/3, gives you minus 4/3, but remember this is an area and we cannot have a negative area, so the area enclosed by the curve y equals x squared minus 1 and the x-axis is 4/3 square units.